talk about virtual local area networks. Pretty easy chapter. Few key points I want you to memorize that you may be asked in the future during a quiz or an exam. So from the name, a virtual local area network. So it is a network, but it is virtual. So there is no physical connections or reconnections. Virtual, or basically it follows the logical layer. So, or logical connections. And it happened using a software. So there's no hardware changes or anything. And it's a local area network. So let's see how it will happen. So a brief introduction here. The virtual LANs, VLANs, they logically segment the switch network. So basically you have a network, you have multiple machines or multiple hosts in that network. The VLAN will segment it or partition it. The switch network based on the functions, project teams, or applications. So you are the one, or the network administrator is the one who set up the criteria of segmentation. And yeah, here it's regardless of the physical location of that network. So all workstations and servers used by a particular work group share the same VLAN, regardless of the physical connection. So pretty much like the paraphrasing the previous statement. Right. So here is an example here. Assume this is a company. It has like this router connected to the internet and there are switches. And notice here, let's assume this is the second floor, this is the first floor. So they are physically apart from each other. So the workstation here in the VLAN group will be restricted to communicate within nodes in the same VLAN. So let's assume these things are color coded. So this one is engineering. This one is business. And this one is law, for example. Now notice here, the law here, they have their own VLAN. Business, similar thing. Engineering, there you go. So they share a restricted communication between them. So what will happen, like what VLAN actually does? When this host here, assume it wants to send a broadcast message. And we know what broadcast is. It sends a message to all hosts within the network. Now with VLAN, I'm restricting this broadcast to only the ones in the virtual network. So the only ones who will be receiving the broadcast message are within the engineering network or VLAN. So a group of ports in the same broadcast domain, and that's the key point here, broadcast domain. We'll talk about it later. This grouping could be happening by using port ID. Now port ID using the switch. So this is the switch. And I think, I'm not sure if we ever did that in Packet Tracer, but the switch has a lot of ports in there. So probably 20 ports, for example. So port ID, the network administrator will just take a group of ports here and group them. That's one VLAN. For example, ports 1, 2, 3, 4. And the other ports here, that's another VLAN. So that's what we call port ID. Now MAC address, if you guys remember, MAC is media access control. And inshallah, we'll talk about it in detail later in the course. So this one is specific for devices. It's a unique number for each network device. So the grouping will be based on the MAC addresses, or it could be on the protocol, on your IP address, or it also depends on the application. And this all is the job of the network admin. The network admin is the one responsible to do all this setup. So LAN switches and network management software provide a mechanism to create LANs. And that's the key point here, a network management software. Why? Basically because there's no change in the hardware. Frame tagged with a VLAN ID. Remember, like when we send the messages, like this is the actual message. Now we have the TCP header, IP header, and then Ethernet header and trailer. And then there will be another header that's a VLAN ID. So the frame will be tagged with that ID. So how do VLANs function? Segmenting the network, logical segmentation into different broadcast domains. That's the keyword here, but just the broadcast. So that packets are only switched between ports that are designated for that particular VLAN. And here is an example here. This is similar to the network or the building example. So we have the servers here. They are in a server room. And like this is server number 1, that's for engineering. This is for marketing, and this is for accounting. And notice, like the whole engineering set, they have their own VLAN, hosts and the server. Similar thing for the marketing, hosts and the server. Accounting, hosts and the server. So each one of them is their own VLAN. So when this device broadcasts a message, it will only go to these devices here. Other ones will not receive the broadcast message. So the routers in VLAN topologies provide broadcast filtering, security, and traffic flow management. Remember, the router is the device that does everything. So it provides the broadcast filtering based on the VLAN ID, security to make sure that the message will not go anywhere, let's say else not desired, and traffic flow management. That's the typical job for the router, but then we add to it the broadcast filtering functionality because of the VLAN. All right, so VLANs address scalability, security, and network management. Scalability basically assume that you want to add a machine to the network. And here is one important thing actually, or feature about VLANs. Now let's assume this network here, this large network, assume a line of 9 gigahertz or gigabit per second. Okay, 9 gigabit per second. So that's the speed of the network. Now this 9 gigabit per second is distributed evenly among each VLAN. So this one is 3 gigabit per second. The same thing here. So each one of them, they share, let's say each VLAN has its own bandwidth. Now assume that you added a device to this network. Now that device will share only this part or this pool of 3 gigabit per second. The other VLANs will not be affected. So that's why it's good for scalability, that even if you add too many users, the only particular VLAN will be the one, let's say, affected by adding a host, not the whole network. If you assume this network doesn't have virtual LANs, the overall performance because of only one computer. But when you have VLANs, the only particular VLAN will be affected. So that's good when it comes for scalable networks, that only VLANs, let's say particular VLANs will be affected, not all the network. So that's one of the example of the advantages of VLANs. Traffic should only be routed between VLANs, and that's what I mentioned. Okay, broadcast domains. So this again pretty much similar. This is exactly the example of before. So again, another building, 3 stories or 3 levels. Engineering group, marketing, accounting, and each one of them has its own server. So this color here, the beige color is VLAN 1, the gray one is VLAN 2, and the green one is VLAN 3. So the switch will create the broadcast domain. This is the one, the switches, or the main switch here also. VLANs help manage broadcast domains. Basically, by the VLAN ID, when the broadcast message will be out, it will be out for only that particular VLAN, not everything else. All right. VLANs could be defined on port groups, users, or protocols. That's up to the network administration to do that. LAN switches and network management software provides a mechanism to create the VLANs. I think we already faced this statement. It's a software thing. So a VLAN is a broadcast domain created by one or more switches. And by the way, one of the key advantages for VLAN is to manage traffic or reduce traffic and manage broadcast domains. All right, now this example here shows one way of, let's say, if you don't have the technology to use VLAN. So this one is kind of a hardware implementation of how the virtual local area network. So in this case, in this particular example, there is no need for VLAN, basically because all engineering computers, they are all connected to the switch, engineering switch, and that will be connected to the router. So this is an example of not using VLANs or a network without VLANs. So there is a switch for engineering, a switch for sales, a switch for marketing. There you go. These are the switches. And all group is connected to their own switch. Unlike the previous example here, there's a switch, but all computers are connected to that switch. Each switch treats all parts or ports as members of the one broadcast domain. There is no software setup, no complications. Router is used to route packets among the 3 broadcast domains. So here is an example, no VLAN. So layer 3 routing allows the router to send packets to the 3 different broadcast domains. So that's just a statement. If you guys remember, layer 3 is the network access layer. All right, VLAN communication. So here is an example again. This is the switch. Again, this one has almost 20 ports. So this is port number 1, port number 2, 3, 4, 5, 6. Port number 4 is connected to the router in this side, and port number 5 is also connected to the router. 1 and 6, they belong to certain VLAN, and ports 2 and 3 were like with another VLAN. So this is what we call a port-based VLAN. Like the division here happened with the ports. So implementation on a switch causes the following. The switch maintains a separate bridging table for each VLAN. So there you go, that's the switch, and has something called a bridging table. So it's basically a table of all the addresses within the local area network that controls the flow of data. Now, what will happen in the case if you receive a message from an unknown port? So if the frame comes into a port in VLAN 1, the switch searches the bridging table for VLAN 1. Now, if the message is not, let's say, is unknown, the switch will add the source address to the bridging table if the source is unknown. Now, destination will be known definitely by knowing the IP address. The destination is checked, so forwarding the decision can be made. Now, for learning and forwarding, the search is made against the address table for the VLAN only. So assume that there was another device here, or computer, and it has an unknown address. Send a message here, and remember, each device will have a VLAN header or VLAN ID. So if this VLAN ID was unknown, once the switch receives it, it will check it, and it will add it to VLAN number 2. Then, whatever the destination is, it will route the message to that one. So this is how the update will happen for VLAN or address table on the switch. So that's what we call learning and forwarding, the search against the address table for the VLAN. Okay, so VLAN operation. We have several VLANs, 3, and notice here that, so there is VLAN 3 here and VLAN 3 here. They are not directly adjacent. So this is the network management station. Static VLANs are secure, easy to configure and monitor. So this is the static VLAN set up by the network administrator. It's not dynamic. Now, each switch port could be assigned to a different VLAN. Again, this is the switch. Has too many ports in there. So let's say, for example, there is a certain range, that's VLAN 1. Another range, that's VLAN 2, and so on. Similar thing for this switch. And you can program the switch ports to certain VLANs. So each switch port could be assigned to a different VLAN. You have 20. Let's say for this one, for VLAN 3, it's assigned 2 locations or 2 ports. For VLAN 2 is only one port, VLAN 1 only one port. And this switch is quite different. VLAN 1 has only one port for PC. VLAN 2 has two ports. So all of these things could happen from the network administrator at port assignment. So ports assigned to the same VLAN, they share the broadcast. And that's a very key point here. Sharing same VLAN means that they share the same broadcast. So if VLAN or this device share the broadcast message, it will go here, and then it will go to these two computers only. Basically, ports that do not belong to the VLAN, they could be considered like they are in a different network. They will not receive these broadcasts. Okay, users attached to the same shared segment share the bandwidth of that segment. I think I talked about it, the 9 gigahertz, 333 each. So that's one way of seeing it. Each additional user attached to the shared medium means less bandwidth. Why? Because it will be divided over a higher number of hosts. And then there will be a deterioration of network performance. Basically, it will not be as fast as before. Now, the good thing about VLAN, it's only the members of that VLAN will be affected, not the whole network. So it will offer more bandwidth efficiency to users than a shared network. So the default VLAN for every port in the switch is the management VLAN. So that's the default. That's VLAN number one. That's management. Every network, when it comes to virtual local area network setup, there's always been a VLAN number one, and that's the management VLAN. So yeah, the management VLAN is always VLAN number one, and you cannot delete it. It's the basic one. All other ports on the switch may be reassigned to alternative VLANs. All right. So there is another form of VLANs, dynamic. It allows the membership based on the MAC address of the device connected to the switch. Pretty much like the one with the switching tables. When the message will be sent to the switch, it will look at the VLAN ID. If it's not there, it will add it to the switching table. So as the device enters the network, it queries a database within the switch for a VLAN membership through the VLAN IDs. So here's an example, similar to the previous one, but now it's checking MAC addresses. How to check the MAC addresses? There's always an inquiry that will happen. There's a query database. So MAC address checked in database. So that's the server, VLAN configuration server here. And it will check with this one. Now, what is the VLAN? What is the MAC address? Similar thing for this other device. So VLANs assigned using centralized VLAN management application, this one here. VLANs based on MAC addresses, logical addresses, or protocol type. We talked about it. MAC addresses, like that's the physical number that is on the network card. Logical addresses, a protocol type based on the IP addressing, class A, class B, and so on. There is list administration wiring closet because it happens dynamically, automatically. There's no say management needs to happen. Notification when a recognized user is added to the network. Yeah, if there is a device that does not belong to the network, there should be a warning sent to, say, to the management system. All right, so we have three types. There is the port-based, based on the logical ports on the switch. So on the port-based or port-centric VLAN membership, the port is assigned to a specific VLAN membership, independent of the user or system attached to that port. So in this one here, the switch, the device will be programmed that, for example, let's assume these are the ports. And for example, here is VLAN 1. And here is VLAN 2. Now assume you bring a host here and attach it to this one. Now, regardless what type this device is, by default, it's going to belong to VLAN 1. So regardless of what device in here, as long as attached to this port, so this is a port here. As long as attached to this port, then this port belongs to, or this device will belong to VLAN 1. So that's what port-based is. That's an example illustrating the idea. Okay, let me remove I did here. It kind of discusses the same. Showing here, this is my switch. There we go. That's the switch. These are the ports. Now, if you connect to this port, you belong to the engineering VLAN. This port, that's the marketing VLAN. This port, engineering. This one is sales. So regardless of what device you connect to, as long as connected to a certain port, it belongs to that VLAN based on that port. And notice here that each port will have its own IP or network address. So all users of the same port must be of the same VLAN. That's the port-based or port-centric VLAN. So it is the network administrator who will assign the port to each VLAN. So there are two methods, manual and static. I don't think it's the correct form. So manual and dynamic. Because manual and static is the same. Manually and statically it's the same. I will fix this one in the slides. Let me fix it right now. Manually, okay. I'll say dynamically and statically. That will be more proper. Okay. So let me stop sharing. Someone sent me something on the chat. Okay, you just remind me. Attendance and also Muhammad Badri, I think. Yeah, remind me once I'm done with the lecture, so I'll mark you both present.
Okay, Doctor. Thank you.
No problem. Okay, so network administrators are the one to, let's say, responsible for doing the setup of dynamic and static. So the static way, remember, like static routing, it has to happen manually. So network administrator configure port by port. Each port will be associated with a specific VLAN. Everything is in manual manner. The network admin is responsible for keying in the mapping between the ports in the VLANs. So just to summarize it, it's manual. Now the dynamic one, the ports are able to dynamically work out their VLAN configuration. So they are configuring based on MAC address or network type. So use a software database of MAC addresses to VLAN mapping, which is the network administrator must set up first. So yeah, the network administrator will need to do some conditioning setup at the beginning. That is for certain MAC addresses, assign them to that particular VLAN. But with the static one, that's it. It's like this. So yeah, pretty much like the one I before. So this range, that's VLAN 1. This is VLAN 2. And this is VLAN 3. So that's what static is. Port by port. Again, using a software. Each port will be associated with a specific VLAN. By the way, it doesn't have to be organized like this, like a checkerboard. It could be just randomly like this. So like this. So this is VLAN 1, this is VLAN 1, this is VLAN 2, 2, 3, 3. It's up to the network admin to decide that. Now the dynamic way, it just, the switch will check the MAC address of the network device of that particular host, and based on this setup, it will assign it to a certain particular VLAN. If it's unidentified, it will raise a flag. It will send a message to the network admin that there's a device that should not belong to the network has been attached to the network. All right, so basically we covered two of, let's say, of VLANs. There is the MAC based and there's the port based. Now we're going to take over the three. So port based, we talked about it. MAC based, we talked about it. So this is static. This is dynamic. And the last one is protocol based. Protocol based is like what network protocol you are using. So this is going to be based on the internet protocol. So the frame headers are encapsulated or modified to reflect a VLAN ID. Remember that, like after the whole message is being encapsulated, it will be also encapsulated with another layer of VLAN ID before the frame is sent over the link between switches. All right, so just a brief, and I suggest you guys memorize or understand the difference between them. That could be a question in the exam later in the future, in the final. So in port-based membership, the port is assigned to a specific VLAN membership independent on the user or system attached to the port. So yeah, we talked about it. So that's going to be manual by the network admin, port by port. Now the MAC address based, it's a dynamic VLAN. And this one is, the first one is static, manual or static. Allow for membership based on the MAC address of the device connected to the switch. So this one is automatic or dynamic. Now the last one is protocol based. It's going to be based on the network address. Process traffic based on the protocol. Protocol based VLAN is used to define filtering criteria for untagged packets. Okay, so here's an example on all of them. So port based, yeah, based on the port number. MAC based, it will look at the MAC address for each device. Now the last one on the protocol based, it's going to look at the network address of each let's say device, the IP address, and will assign VLAN based on that. So yeah, network address driven is pretty much like the protocol based. So those are the three different types of VLANs: port based, manual; MAC based, dynamic; protocol based is going to be also dynamic, because the configuration will happen at the beginning, and then the VLAN assignment will happen dynamically. Okay, almost done, I think. So what are the factors that affect the number of VLANs in the network? The traffic patterns, high traffic, low traffic, how frequent it is, the types of application. Let's say an engineering team have their own, networking team has their own, network management needs, group commonalities. These are just, and there are many, like the list can go more. So the number of VLANs depend on how you're going to do the grouping. Okay, so an important consideration in defining the size of the switch and the number of VLANs is the IP addressing scheme. So yeah, definitely, if you have type C network address. So if it's type C, if you guys remember, each network can support up to 254 users. So VLAN and IP address kind of one-to-one correspondence between the VLAN and the IP subnet, sorry. So it's good to have kind of correlation between them. So you cannot have more than 254 devices in any VLAN, assuming again that's a type C. 254 is the number of hosts you can have in the same network for a class C type of network. So when you do a VLAN, you should not have more than that number in that VLAN, because it's going to be useless to do such thing. Okay, and here's an important part. I want you also to memorize them. They are the sake for mentioning, but we're not going to do any detail, but you still have to memorize them. So methods for frame tagging. Well, the first one is inter-switch link and 802 IQ. So this is an IEEE approach. And this one is not, like that's the standard. So these are the methods for frame tagging used in VLAN. So basically ISL used to be the most common, but now it's being replaced by the IEEE one. And here is just an example how they look like, how the frame tagging will happen. So VLAN and VLAN, the two switches will do that over truncation. the ISL encapsulation, the inter-switch link encapsulation happens this way. We don't have to worry about the details, how this thing happen. Everything will happen automatically with the software. So yeah, it just add all packets together. We'll do some truncation. Whatever this device use, this device will do the reverse. And that's pretty much it for this chapter. Just memorize these two concepts, ISL and 802.IQ. So no intrusive to client stations. Client does not see the header. Yeah, as I mentioned, everything will happen automatically between the two switches. So whatever is added here will be stripped or taken away in this one. And that's it about VLANs. The concept is quite simple. Just memorize that VLANs are meant to reduce traffic or manage traffic, and also to separate broadcast domains. Two technologies for encapsulation, ISL and 802.IQ. ISL was the prior, before it has been preceded by 802.IQ. So this is it for this lecture. Any questions? Any questions on VLANs? I know the lecture was short, and that's why I decided the quiz will be in this lecture, because also the lab is going to be short. So any questions before we go to the lab? Let's have like about 5 minutes break.